Hey everyone, here I welcome you all to the BSL Academy. Hope you are fine and healthy and preparing for the JAC board examination of class 12th. So, I want to tell you one thing that we have already covered all the important questions or PYQs of your physics paper of JAC board in the previous sessions. So, today we have come with one more wonderful session which is on organic chemistry. So in organic chemistry today we will discuss the all important naming reactions of class 12th, which is based on the new syllabus of the JAC board. So let's start. So here you can see the index. Here I have added all important naming reactions. First, Sandmeyer reactions, Finkelstein, Schwarz, Wurz, Riemann-Tiemann, Rosenmund reaction, Stephan reaction or Stephan reduction, Clemenson reduction, haloform reaction, aldol condensation, Cannizzaro reaction, Friedel-Crafts reaction, esterification or Fischer esterification, Williamson synthesis, very important. And these are also very important: Sandmeyer, Finkelstein, Wurz, diazotization, Hofmann bromamide degradation, carbylamine reaction, Hinsberg test, and Grignard reagent. So let's start. Today we will discuss these reactions one by one. So the first one is here, you can see Sandmeyer reaction. So I want to tell you one thing, that diazotization reaction and Sandmeyer reactions are almost interrelated. So in this reaction we will discuss about both. The diazonium C6H5N2Cl is prepared by treating ice cold solution of aniline C6H5NH2, the formula of aniline, in excess of dilute HCl with an aqueous solution of NaNO2 at low temperature 0 to 5 degrees Celsius, and the reaction is known as diazotization reaction. So this is your diazotization reaction, and here you can see aniline changed into benzene diazonium chloride in the presence of HNO2 or HCl or NaNO2 plus HCl at temperature 0 to 5 degrees Celsius. So this is your diazotization reaction. And for Sandmeyer reaction, this reaction is proceed. Bromo and chloro and CN. CN stands for cyanide. Nucleophiles can easily be introduced in the benzene ring of benzene diazonium salt in the presence of Cu1. 1 stands for its oxidation state. Cu ion. This reaction is called Sandmeyer reaction. So this benzene diazonium chloride changed into chlorobenzene or bromobenzene in the presence of Cu2Cl2, Cu2Br2 respectively. So this is your Sandmeyer reaction. And also you have seen here diazotization reaction. Let's move on the next reaction, which is your Finkelstein reaction. Alkyl iodides are often prepared by the reaction of alkyl chloride bromides with NaI in dry acetone. This reaction is known as Finkelstein reaction. So this is very easy. Here you can see Rx plus NaI yields Ri plus NaX. X stands for halogen, in which only chlorine and bromine are included, and R stands for methyl group. Now next, Schwartz reaction. Heating an alkyl chloride or bromide in the presence of metallic fluoride such as AgF, Hg2F2, COF2 or SbF3 gives alkyl fluorides. The reaction is formed as Schwartz reaction. So here you can see CH3X, X means halogen, chlorine or bromine, plus AgF gives CH3F plus AgX. So here you can see the displacement reaction occurred, CH3X and here CH3F. So this is also very important reaction and also very easy. Now next, Urch reaction. This is your most important reaction and you most have to learn this reaction. When alkyl halides react with sodium in dry ether to give hydrocarbons contain double the number of carbon atoms present in the halide, the reaction refers to Schwartz reaction. This is not Schwartz reaction. So by mistake I have write Schwartz reaction. This is Urch reaction. So please correct it. And here you can see its reaction, CH3Br plus 2Na plus BrCH3 in the presence of dry ether yield CH3CH3. So as the statement that it will provide you double the number of carbon atoms. So here you can see CH3CH3 which is ethane. We have used here methane and here we have get ethane plus 2NaBr. Similarly, C2H5Br plus 2Na in the presence of dry ether gives C2H5 which is N-butane. So again double the number of carbon atom. Here only 2 atoms of carbon and here you can see 4 atoms of carbon. Now let's move on the next reaction, which is Riemann-Tiemann reaction. On treating phenol with chloroform in the presence of sodium hydroxide, alpha CH, this is A CHO group is introduced at ortho position of benzene ring, resulting salicylaldehyde. This reaction is known as Riemann-Tiemann reaction. So here you can see its reaction. Here we have get salicylaldehyde. So this is the structure of salicylaldehyde. This is benzaldehyde and this is alcoholic group on its ortho position. Next, Rosenmund reaction. Acyl chloride or acid chloride is hydrogenated over catalyst palladium on barium sulfate. This reaction is called Rosenmund reaction. So this is your benzoyl chloride treated in the presence of S2 PdBSO4 and gives benzaldehyde. Now next, Stephan reduction and Rosenmund reduction. This is also a reduction reaction and Stephan reaction is also a reduction reaction. Here you can see nitriles are reduced to corresponding imine with stannous chloride in the presence of hydrochloric acid, which on hydrolysis give corresponding aldehyde. This is your nitrile group treated in the presence of stannous chloride and HCl gives RCHNH HCl. This is your imine and on hydrolysis it will give the aldehyde group plus NH4Cl. So RCOH is your major product. Now next, Clemmensen reduction. The carbonyl group of aldehydes and ketones is reduced to CH2 group on treatment with zinc amalgam and concentrated hydrochloric acid is known as Clemmensen reduction. This is the reaction for Clemmensen reduction. Here you can see the ketonic group changed into the alkyl group. Now next, aldol condensation. This is the most important reaction. So please read it carefully and practice it. In the reaction, two molecules of an aldehyde or ketone condense in presence of a dilute alkali, dilute NaOH or Na2CO3 or BaOH alcohol to etc. to form a beta hydroxyaldehyde or beta hydroxy ketone respectively. These beta hydroxyaldehydes or ketones are collectively known as aldols. So this is the reaction for the aldol reaction or aldol condensation reaction. So here you can see the aldehyde group changed into the beta hydroxyaldehyde in the presence of dilute NaOH, and here ketonic group is changed into the beta hydroxy ketone. Now next, Cannizzaro. So this one is also important reaction for the JAC board. Aldehydes which do not have an alpha hydrogen. So here aldehydes is given undergo self oxidation and reduction, which is also known as disproportionation reaction. So Cannizzaro reaction is a disproportionation reaction on treatment with concentrated alkali. In this reaction, one molecule of the aldehyde is reduced to alcohol while another is oxidized to carboxylic acid salt. So here you can see formaldehyde which don't have any alpha hydrogen. So here criteria is what? Don't have any alpha hydrogen atom. Treated in the presence of KOH and gives finally what? Methanol and potassium formate. So this is the product. And benzaldehyde changes into benzyl alcohol and also gives sodium benzoate. So this is your Cannizzaro reaction, also known as disproportionation reaction, because it undergoes self oxidation and reduction, and the criteria of this reaction is what? Don't have any alpha hydrogen. So next one is Friedel-Crafts reaction. So in Friedel-Crafts reaction we will discuss two types of reaction. First is alkylation and next one is Friedel-Crafts acylation. So what is alkylation? When benzene is treated with an alkyl halide in the presence of anhydrous aluminum chloride, alkyl benzene is formed. So there are too many examples of this reaction. So let's discuss few examples. First one is your benzene plus CH3Cl. This is your alkyl halide and this is treated in the presence of anhydrous AlCl3 and gives what? Here you can see toluene plus HCl. And again chlorobenzene is treated with CH3Cl. So what will happen here? Here you can see that the methyl group attached on ortho and para position. So the 1-chloro-2-methyl benzene will the minor product and which is on the ortho position, and 1-chloro-4-methyl benzene is the major product. That means this is one para position. So para wala is the major and ortho wala is minor. Now next, acylation. So here we have discussed about alkylation and there are many examples of it. So we have discussed very few examples, so you can understand. Hope you will understand. So let's discuss about acylation. The reaction of benzene with an acyl halide or acid anhydride in the presence of Lewis acids AlCl3 yields acyl benzene. Here you can see acetyl chloride. This is your acetyl chloride. Next example is and CH3COCl. Treated in the presence of anhydrous AlCl3 again and heated, then it's changed into acetophenone. So this is your acetyl chloride changed into acetophenone, benzene changed into acetophenone. Now next, one more example is given here. Chlorobenzene again treated with these reagents changed into the 2-chloroacetophenone, which is your minor product, and para wala is the major product. So ortho minor and para major. Now next, Fischer esterification. This is not very important reaction, but esterification is given in your syllabus, so I have added this. When a carboxylic acid is treated with an alcohol and an acid catalyst, an ester is formed along with water. This reaction is called the Fischer esterification. So carboxylic acid changed into ester in the presence of alcoholic group, which is your alkyl alcohol and acid catalyst, and release H2O. Now next, Williamson synthesis. So this is the most important reaction. It is an important laboratory method for the preparation of symmetrical and unsymmetrical ether. So this is very important, that this is used for what? Symmetrical and unsymmetrical ether. In this method, the reaction between alkyl halide and sodium alkoxide occurs. So here you can see its reaction, and please practice these reactions more and more times, so you will perform better in your examination, because naming reaction is the important part of organic chemistry. So RONA, this is the nucleophile sodium alkoxide, and this is alkyl halide RX. This undergo the SN2 reaction. What is substitution nucleophile reaction, and finally gives ether, what, ROR plus NX. Now next, Hofmann bromamide degradation reaction. This is also most important reaction. In this degradation reaction, migration of an alkyl or aryl group takes place from carbonyl carbon of the amide to the nitrogen atom. The amine so formed contain one carbon less than that present in the amide. Here you can see its reaction, so please see. The carbonyl group, this stands for acetamide, changed into the amine, and same thing occurs with the benzene ring. Now next, carbylamine reaction. This is also the important reaction. So what happened in this reaction? Aliphatic and aromatic 1 degree amines on heating with CHCl3 plus KOH form isocyanides or carbylamines, which a foul smelling substance. 2 degree, 3 degree amines don't show this reaction and used as a test for 1 degree amines. So this is only for the 1 degree amines. See, RCH2NH2 in the presence of CHCl3 in the basic medium or alkaline medium gives RCH2NC. This is isocyanide group. Same thing occurs with benzene ring. Now next, Hinsberg's test. So this is very important test. Benzene sulfonyl chloride C6H5SO2Cl, which is also known as Hinsberg reagents. So learn carefully the formula of Hinsberg's reagent C6H5SO2Cl. This is beneficial for you. Reacts with primary and secondary and also tertiary amines, not tertiary amines, only primary and secondary amines to form sulfonamides. So benzene sulfonyl chloride reacts with primary amine, yields N-ethyl benzene sulfonyl amide. The hydrogen attached to nitrogen in sulfonamide is strongly acidic due to the presence of a strong electron withdrawing sulfonyl group, hence it is soluble in alkali. So here you can see its reaction. Here benzene sulfonyl chloride changes into N-ethyl benzene sulfonamide, which is soluble in alkali. In the reaction with secondary amine, here we have talked only primary amine. So let's talk about the secondary amine. N-diethyl benzene sulfonamide is formed. Since N-diethyl benzene sulfonamide doesn't contain any hydrogen atom attached to nitrogen atom, it is not acidic and hence insoluble in alkali. So primary is soluble in alkali and secondary is not soluble in alkali because it don't have any hydrogen atom. So similarly you can see its reaction too. And next, tertiary amines do not react with benzene sulfonyl chloride. So here the story of primary, secondary and tertiary. Now next we will talk about Grignard reagent. So haloalkanes and other compounds with halogen atom bonded to either sp3 hybridized or sp2 hybridized carbon atoms or aryl and vinyl halides react with magnesium metal to yield organomagnesium halides called Grignard reagent. Grignard reagents are usually prepared in diethyl ether. So what happened with the Grignard reagent? It is used for increasing the carbon atoms, and forced reaction is also increased the number of carbon atoms, but by Grignard reagent we can increase the number of carbon atoms depending upon us. So हम जितने कार्बन चाहें ग्रिग्नार्ड रिएजेंट का यूज़ करके बढ़ा सकते हैं, उससे भी बढ़ा सकते हैं, बट ग्रिग्नार्ड रिएजेंट की मदद से हम अपने मर्जी से बढ़ा सकते हैं. So here you can see an ether solvent is essential for the reaction. The French chemist Victor Grignard discovered this reaction. So for words this is not important. Remembering the name of scientist, but for general knowledge you can learn it, and it has been studied and used extensively ever since. So this is very important reaction and very useful reaction too. So here you can see CH3, CH2, 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 Br plus Mg and diethyl ether changes into CH3, CH2, 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 Mg, Br. and here you can see its mechanism. So mechanism is not important for your board examination, but here you can see. So let's see carefully, and hope you studied it before. So let's watch it, because mechanism is not very important for your boards. So Grignard reagent form easily from 1 degree, 2 degree and 3 degree alkyl halides. Okay, although their reactivities differ, they but it formed easily. Aryl and vinyl halides react somewhat more slowly, and the cyclic ether tetrahydrofuran is required to prepare for Grignard reagent. So this is important, that cyclic ether tetrahydrofuran needed or required for the preparation of Grignard reagent compound. This The higher boiling point of the cyclic ether provides more vigorous reaction conditions, but the rate of reaction also increases because TFH solvates the Grignard reagent better than diethylethan. So here you can see its preparation. So this for your, again I am showing you. See, these were your more important reaction of JAC board. So please learn these reactions more and more, and practice it more and more times as possible. And one more thing, that mechanism is not needed for JAC board examination, so learn only statement and reactions. Because it will be very beneficial for you. So this is it. So hope you like the video. So let's meet in the next video very soon. So like, share and subscribe our channel, so that we always come with the great joy to help you in cracking your JAC board examination. So let's crack the JAC. So bye bye, take care.